So this is a inelastic collision. So in order to solve this kind of problems, it's better to draw diagram, figure, picture, some drawings, because it will help us to solve it very quickly. So this is a bullet M1. Its initial velocity to the right, and let's call it V1. It's unknown. We should find this velocity. And we have a second wooden block, wooden object. Its mass equal to M2. And its initial velocity equal to 0, because it was stationary initially. This is what we know. This is a picture, figure, diagram of our problem before collision. So after collision, since this is inelastic collision, so bullet will stuck in the wooden block and they will continue as one object. So further we have one object, bullet inside the wooden block, and the total mass M1 equal to M2, and they will continue with velocity V3. This V3 is a velocity just immediately after the collision. Immediately after collision. So here, as you see, we have a collision, inelastic collision in one direction. Everything is happening in one direction, in X direction, let's say. Let me draw it also. So this is our X direction. And we know that from conservation of momentum, initial total momentum of the system should be constant. And we know that the momentum is a vector quantity. It means magnitude and the direction of the total momentum should be same. Okay, so let me write it here. Sum of the initial momentum should be equal to sum of the final. It means total momentum after collision. And it's vector actually. But since we have a collision in one direction, so we have only one component basically. This question is very simple. So initially we have only one momentum of the bullet, because second one is stationary, zero velocity. So initially we have only M1 V1, momentum of the first object. Finally, after collision, again we have one object. Total mass M1 plus M2, and they will continue with velocity V3. Before collision we have one momentum. After collision also we have one momentum, so it's very simple. They should be equal to each other due to the conservation of momentum. So from here, V1 equal to M1 plus M2 times V3 over M1. So we can find initial velocity of the bullet by using this equation. But we have one problem. In this equation, V3 is unknown. So first of all, next step, we should find V3. So this is the second step. Let me draw it again. So immediately after collision, here we have a bullet inside the wood, total mass M1 plus M2. And the initial velocity for this stage, it will be initial velocity V3. Due to this velocity, this object will raise to certain height. And this height is given for us. It's 5 centimeters. So this part is conservation of energy. Initially, this system has a kinetic energy, this system. M1 plus M2 total mass, V3 square over 2. This is the initial kinetic energy. And because of this kinetic energy, it will raise to certain height and it will stop. It will be its maximum height. It means kinetic energy, initial kinetic energy will be converted to the potential energy. And the potential energy at its maximum height will be its mass, total mass, times gravity times height. So from here, we can easily find V3, which is 2 times gravity times height square root. That's all. Now we can come back to the initial first equation and substitute V3, and finally we can answer for this question. So V1 equal to M1 plus M2 over M1 times V3, which is square root 2 times gravity times height. So mass 5 gram. Let me solve it in grams, because mass over mass, it will balance each other. 5 grams. Second mass is 1 kilogram, which is 1000 grams over 5 gram times 2 times gravity, approximately, let's take as a 10, height 5 centimeters, it should be in meters, 0.05 meters. So from here, initial velocity of the bullet will be equal to 2 times 10 times 0.05, it's 1, so answer is over 5, 201 meter per second. This is the initial velocity of the bullet. With this initial velocity, the wooden block can raise to the 5 centimeters. So second question, we should find the loss in mechanical energy due to the collision. So we need to come back to our first figure, first picture, first diagram. During this collision, there will be heat, or we can say loss in mechanical energy, which is heat basically, because we have an inelastic collision. So again, energy conserves, it means total initial energy should be equal to total energy after collision. So let's say initial total energy should be equal to final total energy due to conservation of energy. Initially only bullet is moving, so it has kinetic energy. That's all. After collision, we have one object with total mass M1 and M2 with velocity V3 just immediately after the collision, and we have some energy that will be lost during the collision, Q. We should find this Q. So this Q equal to M1 V1 square over 2 minus M1 plus M2 V3 square over 2. That's all. First of all, let me calculate V3. 2 times 10 times 0.05, which is 1 meter per second. So Q equal to M1 is 5 grams in kilograms, 0.005 over 2. V1 is 201 square minus total mass M1 plus M2 will be 1.005 in kilograms over 2, 1 square. So Q equal to it's 105 joules. Of course, we use it as a gravity 10, approximately 10. That's why we may have some a little bit different answer than book's answer solution. Same solution, but the result might be slightly different due to the gravity, because in books they use as a gravity 9.8. We here, to make it simple, I use a 10 meter per second square.